Hi guys, today we're going to talk about machine learning problem. So in the previous video I explained you some data transformation using pandas. I just remember you, we're going to download data for several tickers. For example, for the last 30 days it would be a time frame 5 minutes, and we processed this data to get something correct data frame when we have on the same time, like 5 minutes, several different data from tickers. You see, for example, like this, on this minus 5 minutes we have data for Cardano, for BNB, Bitcoin, and we're going to input this data into a machine learning to train model, identify what would be price if you have open high low close volume feature. So today we are going to use a simple model. It would be a linear regression, and also we used polynomial feature. It's data processing our data. Also, we're going to use pre-processing like a standard scalar. So the first what we need to do is we split our data set on X-train and X-test. Next, we need to make some data transformation. In general, we have three ways to transform our data. It likes rescaling this object from sklearn like min-max scalar. Second, it is standardization and normalization. This approach improve results for machine learning in general. For example, if you use the first approach, our data set would be between 0 and 1, and it increase our computation speed for algorithm. If you use standardization, we do some processing to make a normal distribution with mean of 0. If you use normalization, it means we do some processing, and it would be very useful if you have some sparse data set for attribute. Sometimes we have really object in our data set, and we need to do some correct way to processing this data. And this normalization could help us to improve our results. For example, I used it when I get some signal from statistics, and if this signals happens very rarely, I used this normalization. The first what you need to do, it create object like scalar. We call our class like a standard scalar, and we need to fit our X-train. Next, we use this object to process our X-train and X-test, and we create two new data frame like standardized X-train and standardized X-test. You should use the same object to transform this data on X-test or for production. It's very important because we have some logic here, and this logic would be should be same if you used this transformation for X-test data or for validation data, or if you use it for production. When you create some machine learning strategy, you should to have some simple stage. For example, the first step would be create very simple model, and next we should improve our model and do our logic more complex. First of all, we need to create, for example, linear regression model and compare this basic model from another model what we're going to use. Linear regression model is very old model, and this model very good studied of multiply of people, scientists, and we could interpret these results very easy, and this is advantages for this model. For example, if some investor firm or trading firm make decision using this linear regression model, and we could very good interpret these results to understand what happened on the market. Another situation, if you use deep learning and make decision from some black box. But deep learning is another approach, and there are some advantages when we could achieve using stochastic some bugs. Explain you in next time. So for example, we create this object linear regression. Next we transform our data set, and you see, for example, we used our standardization and Y-train, and we train our model, and we get some object. Next we need to use this object model to predict our data, and we get some predictional results, and we calculate mean square error. And you see, for example, we have 25 RMSI for this linear regression. If this results would be decreased, it's very good for us. Next, we need to improve our model. I did some note for you, and for example, we are going to use polynomial feature to process this data to achieve the best results, for example. Because when you use linear regression, sometimes in data set we have some non-linear dependency, and we could get this dependency using this approach, like polynomial feature. So we do this processing, we create this object and identify, for example, coefficient 2, and we do this processing. Next we also create the same, we create object of linear regression. Next we train our model. Next we predict our data and get some RMSI, mean square error. And you see this result is decrease. It's very good. It means this approach working. And next we need to do some tuning model. It would be the next step. So the first step, it creates some simple model like linear regression. Next we need to improve our results using, for example, data processing like polynomial feature. And next we need tuning our model, because and you see this object get degree, and you could tune this coefficient to find the best relationship with non-linear dependency. Okay, how to do it? We create our parameters. It would be a list of array from 1 to 10, and we need to input this data into a polynomial feature. Next we need to input these results into our empty list, and it would be results and names. So we do it using loop, and we create this new polynomial feature. It would be, if you loop in these params, the first iteration would be 1, the next iteration would be 2. Next we need to create our polynomial feature and train our model. And when we do it 10 times, we get 10 results. And you see? So it means when we used 10, and our result is decreased. But here we have some logic, and we need to find the lowest value here. To do it, what you need to do, it's run this cell. So we used comprehensive iteration here, using enumerate and find a minimal value. We find minimal value of results, because in results we have some results of this RMSI, and we need to find the index of a small value here, the minimum value. Next, we need to input this index into names, and we get what is the names. When we do it, it means the best for train would be if we have 4. It means a degree would be 4. It would be the best results. Okay. Also, we need to check this approach for test data. This logic is similar, but we need to use the test data. You see? And sometimes we need to check the results, how it difference between these images. But in general, you see these images is similar, but the best way if you used degree is 1. But let's imagine it would be some production data, I mean test data, and we need to use the results from trained data like here, and we used degree 4. I mean this coefficient to transform our data set using polynomial feature. So let's create the simple model. It would be a final model when we did some simplest tuning our model using linear regression in polynomial feature. So let's input all the best results of train 4 means, and input into this cell, and you see we have some polynomial feature transformation, and we create object linear regression and train this model and calculate our results on test data, and we got some RMSI, and you see RMSI for the polynomial regression of final 8, so it's less than our model, what we create like a basic model. It means we did some tuning and we increase our results. This logic is simple from data science. For production we have, for example, multiply of models, different approach. It takes some time to make research, to do research. It could be take several weeks, for example, if you take different approach, and for example, if you change some feature of our data set, input different of models and tuning these models to achieve some of the best results. Next, we need to apply these results for machine learning in trading to understand how it's working. It would be in next time. I explain you and I show you how to use this information to create some trading strategy, and we check the strategy, and it would be some tutorial how to use some linear regressional model to create trading strategy. And next we are going to use some feature of linear regressional to improve our results using some batch size of a data set. I explain you why it's very important. So guys, use this notebook to research this problem, and if you like this video, subscribe on my YouTube channel, and see you next time. Bye.